Welcome to this Grasshopper tutorial about basic vectors, where we'll be setting up a multi-point vector field to shape a series of striped lines. Inspired by Topotech 1 and Big's Superkylen Park in Copenhagen, Denmark, in this video we will be using Rhino and Grasshopper to create a field of linear striped geometry, which distorts itself based upon each stripe's relationship to several customizable distortion points. You will then be able to modify the strength and radius of the distortion effect along with the location of the points to create unique patterns. In this tutorial, you will learn how to set up vectors between points based on a closest point analysis, how to change the strength or amplitude of vectors in Rhino and Grasshopper based on distances from the attractor points, how to link points together with the interpolate curve component, and finally, various strategies to improve the visual presentation. Let's get started. We're going to start by creating a grid of points. We're going to do it in a slightly different way. Instead of using the square grid component, which we could use, we're going to use in the third tab set sequence series. I'm just going to drop one series down on the canvas, and for now the only component I'm going to change, the only parameter I'm going to change is the count, and I'm going to draw a slider, double click the canvas and just type 60, and this will give you a slider between 0 and 100 with the value set at 60. And I'm going to take this and copy this, Control C, Control V, and my second series will have a count of, let's just say 25. So from these two series, I'm now going to construct a grid of points. And so to do that, the fourth tab, vector point, I'm going to use this construct point component, drop that on the canvas, and our first series, our 60 count series, we're going to use that for the X, and so now we have 60 points in the X direction based on this series. And now for the Y input, I'm going to use the 25 one, and so now we have 25 points. We still have 60 points because it's basically drawing a point at 0, 0, 1, 1, 2, 2. But when it runs out of Y values, it just repeats the use of the final Y value there. We want a grid though, and so to do this, we're going to go onto the Y input of our construct points, right click that and graph that. So what the graph is now doing is for each one of the 60 X values, it's using the first Y value, and then for each of the 60, it's using the second Y value, etc. So now we have 60 times 25 points in our field. So I'm just going to skip ahead ever so slightly, because just to show you in the end what we want is a series of stripes going in either the horizontal or vertical direction. So to preview our stripes, I'm going to come here under the curve component, spline, and use an interpolate curve component, and I'll use those points as the V input on my curves. I'm going to turn the preview for my points off for just a minute. So these are going to be the stripes. Now note, if you had grafted the X values instead, you would get vertical stripes, which we could do. But for now, we just want the horizontal stripes as you're following around. You could also create this with the square grid component. As I said at the beginning, take the areas for our points, and then use those points to, let's just turn this off for just a second. And let's turn our square grid off. So here the points will give you vertical stripes only. And if you want the horizontal stripes, you can use a component called flip matrix. which will flip the data structure or change the data structure of that grid of points, and you can get horizontal stripes. So 2 ways to get to the same point. So let's just go back. I'm just going to turn these on and zoom out to my field. And what I want is, I want my stripes to bend or move away from a series of points which I'm using as vector orientation points. So I'm just going to draw maybe just 3 points in somewhere in this field of stripes, and I'm going to use those as my orientation points. So I'm going to come here under the first tab, Parameters, Geometry, Point. Right-click that and say Select Multiple Points, and I'll select the 3. You could do 5 points if you want or more in Rhino. And I'm going to select this points parameter, put this into a group, and I'm going to call this Stripe Bend Points. And I'm going to delete now my interpolate curves, and I'm going to put these output points into another points container, and I'm going to call this, put this into a group, and I'm going to call this Stripe Reference Points. So these are the points which are going to be used to draw my stripes, and these are points which are going to be used to basically push the stripe reference points away, and we'll see how that looks by the end. So once you've gotten this far, we're ready to move on to the next step. So what we're going to be doing is we're going to be moving our stripe reference points away from our vector orientation points or our stripe bend points, and we're going to be using, eventually, you don't have to do this yet, but we're going to be using the transform move. So move requires 2 inputs, a base geometry and a motion vector. So the motion vector will be motion away from these particular points. So that's what we're going to do, and so what we want to find is a T input which will give us the results that we want. I'm going to delete that for now. So before we can do that, though, we have to find out which one of these stripe bend points is the closest to each one of our stripe vector points, and then we need to find that vector. So what we're going to do is here under the 4th tab, the Vectors tab, and the Point subtab, we're going to find the closest point to each one of these reference points. So we're going to use the reference points as our P input on closest point, and we're going to use our stripe bend point as the C input, or the cloud of points to search to. So we get these results. Nothing has changed yet, but we do get the dimensions of the closest point, the coordinates of the closest points here. So these are the reference points, and we also get the distances to those points, which will also come in handy in a bit. Before we can do that, though, we need to find the vectors between our stripe reference points and our whichever point is closest to it. So vector, and then the vector subtab, and vector 2 points. Let's drop that on the canvas. The A input will be our stripe reference points. The B input will be whichever one of those points it is closest to. Still, we don't see anything changing in Rhino, and what we're going to do as an optional step is just display those vectors just to make sure it's working properly. So here under the Display tab, Display Vector subtab, Vector Display, we'll just drop that on the canvas, and we'll use our stripe reference points as the anchor and the vectors which are being produced here. And so if it's working properly, you will see these arrows or lines being drawn between each one of the reference points and the orientation or bend points. And if we move these, they should update it should update the vectors based on any movement I do here. So if that's working properly, we're now ready to move on. So this is where things will start to get a little bit tricky. So please follow along closely to understand the logic of this. So what we're going to be doing now is we're going to be taking our stripe reference points and we're going to be moving them. So let's just do this step by step. Let's come here to our move transform. So under transforms, Euclidean move. Drop that on the canvas. So we're going to be taking our reference points. Let's just put them into the geometry input on our move component. And we're going to be moving them along a translation vector. So if we take our vectors that we've identified through the closest points process, and we just drop those in, it has moved our reference points. Let's just turn a few of these things off. So the vector preview off. Let's turn the reference points preview off. And we'll even turn our bend points preview off. What it's done is it's moved all of our reference points to the bend points. So what it's done is it's moved it along the entire vector length, and that's not what we want. So it looks like there's 3 points. There's actually 1,500 points, but they're all congregated or clustered around these 3 bend points. That should give you a clue, though, as what we need to do to fix this. What we need to do is we need to adjust the vector length or the vector amplitude. And so let's just come here under the vectors tab, vector subtab amplitude, and let's drop that on the canvas. We'll put all the vectors we've identified into the V input on amplitude. And for now, let's just put a value of 3 into the amplitude input just to see what it's doing. So I'm going to use this one instead for my movement. And you can see as I adjust this value that it is moving 1, 2, 3. And if you increase it enough, it's actually starting to move it over or beyond the bend points, 7 units, etc. So this is movement towards the bend points. We actually want the movement to be away from the bend points. So let's just come here under maths, operators, negative, to get the negative value of the amplitude. Let's drop that into move, and you can start to see it's starting to go in the direction that we want, where we are moving away from these points, and yeah. But currently it's moving all the points away in equal amount. And what we want them to be doing is we want them to be moving away more the closer you are to the bend points. And as you move away from the bend points, the movement will be less. So what we need to do is we need to incorporate some of the logic from our attractor scripts. I've made a link to one of those in the description that you can check out if you haven't worked with attractors before. But we'll be doing the same thing. We'll be combining the logic of attractor scripts into our vector field to adjust the movement. So you'll remember in the attractor fields, if you've watched the videos, that the distance is the key component which influences the strength of our attractors. Now currently, the closer you are, it's going to be less distance, and the further away you are, it's going to be more distance. But we want the attractor to be, the closer you are, that there's going to be more movement. So that could give you a hint as to what we need to do. We need to basically invert our field, our series of distances, by subtracting those from a value. I'm just going to double click on the canvas, type 1.5. So what I'm going to be doing is I'm going to be subtracting with math operators subtraction 1.5 minus my distances to get a result. And I'm going to, let's just put a panel in to see what those look like. So negative 18, etc. Currently, this is going, if I just use these for the movement, that's quite a bit of movement, quite excessive amounts of movement. So there's one other thing I'm going to do right now, and that is to divide the distances by a factor. So here under operators, division, drop that on the canvas. So I'm going to take the distances before I put them into the subtraction and just divide those by a factor. And for now, I'm just going to type 2.5. We'll be able to adjust that later to go into this. So these are the distances I'm now using to influence my movement. Now, if I put those into the amplitude right now, you can kind of start to see as I increase the factor, or if I increase the cap, it's starting to do something. Eventually, we'll get to exactly what we need, but you'll see at a certain point, we actually want our movement to stop. Currently, it's actually moving a lot of our items too much. When I have a very large negative value, it's moving quite a bit. So one other thing I want to do is I want to cap the movement at a certain point. And what I'm going to use for that is I'm going to use the maximum component. So here are their maths utilities, maximum. And since most of my distances are negatives, I'm going to cap those at 0. So these are now capped at 0. So anything that is less than, less than 0 is now just being returning the value of 0. And now I'm going to use those for my amplitudes instead. So we're going to clean up what we've done here in just a moment, give names to everything. But for now, I just want to check to see if everything is working as intended. So what we want to be doing is drawing these stripes, and if you remember from the beginning of the video, what we're going to be doing is using an interpolated curve. So here, the 5th tab curve, and then the splines sub-tab interpolate. And we're going to use the moved points as the vertices for our interpolated points, interpolated curves. So let's turn the preview for that off. Looks a bit like Jupiter's atmosphere. So I have the 3 points, and if I start moving these around, you can see it is doing what we want. You can see if you move a bit too close, some wonky stuff starts happening, but so you do have to use some discretion in this example. We could also draw a couple more points in Rhino, just to come back here to the stripe bend points. Let's set a few more points. Enter. Sorry. Set multiple points. Enter. So yeah, it is working. And you can just change the composition. And one other thing is here I can change the graft of my points to the X direction to get those stripes going in the vertical orientation. So let's just rename a few of these parameters. There's a slider I need to delete. This was used for amplitude. Let's get rid of that. So this parameter, as I change it, it's starting to influence the fall off radius. So I'm just going to rename this one effect. Not sure if it's effect with an E or an A. Maybe it's effect with an E or an A. We don't know. And then this one also increases the radius, but what this does is the rate at which that effect's applied. So here we have high amounts of offset close, and then as I move that away, it's changing what's the fall off of that effect. So fall off effect radius. Maybe someone could put in the comments if it's effect with an A or an E. So those are the parameters I have, and I can start to change those. And then what we do with these lines, we can just look at briefly in the last step. So now that we have our curves, there's a number of things we could do to make this look more visually appealing. I'll just show you two ideas I had. You can come up with your own as well. So we have the curves. Let's try to make some stripes which have a color. And to do that, what we're going to take is our curves, and we're just going to offset them. So here under curve, utilities, offset. So we're taking each one of these and we're offsetting them. Currently it's doing a little bit too much, so the distance here is 1, which is basically our grid spacing. So let's make that distance be something smaller, like 0.2. And we could put a slider on as well, but here I could just manually change the value. And so now I have a number of curves offset, and what I could do now is just create some surfaces. And we can't create boundary surfaces because we don't have closed edge curves, but we could use this one here, edge surface, create a surface from 2, 3, or 4 edge curves. And what we're going to take is our curves from the interpolated curve, put those into input A, and the offset curves, we'll put those into input B. And so now we're getting some thickness to those. And I could come here under display, preview, custom preview, parameters, input swatch to give those a color. The project I was inspired by for this one was white stripes on asphalt. So I'm just going to try and actually make this white. But currently you can't see those edges. Just make them black again for just a second. We'll change it to white in a second. So what I want to do is just take the endpoints of all these. And so these curves, let's take the endpoints. So curve, utilities, let's see, where is that one? So it's under curve analysis, endpoints. So let's take the endpoints and let's just do another interpolated curve, one through the start points. Let's flatten those. And then one through the endpoints, and let's flatten those. The reason I'm flattening them is because they have a data structure which doesn't allow you to make an interpolated curve, but now I have this. And then I'm going to do that same process with the edge surface, edge surface, and I'll just use these two curves for my edge surface. Let's turn the preview for that off. And I'll just copy over this custom preview I already have, make that black, and then I'll make this one white. And so now I have these stripes, but currently they're occupying the same space in the Z value. So what I'm going to actually do is I'm going to move these edge surfaces just a little bit in the Z or Z direction. Unit Z. Let's just make it 1 unit. And then put that into the custom preview. And let's turn that off. So yeah, now I have stripes on a dark background. Another thing I could do, which is just a little bit simpler, I'm just going to turn the previews for those off, is I could come here under surface pipe, and what this will do is it'll create a pipe or a extrusion around each one of my edge curves. So let's come back. We're just going to ignore all this for now, and just come back to my interpolated curve and drop that into the pipe component, and then set a radius, and let's just have our radius be 0.25, and this will give us some pipe-like geometry. Just going to put a custom preview on this and give that a color, parameters, input, swatch. And let's just give it a darker color. So now I have these. I could bake these into Rhino. And let's just close out a Grasshopper. And now that these are baked into Rhino, I'm just going to close Grasshopper altogether. I can now start to convert these into a mesh, 3D print them, etc., etc. If you would like access to a cleaned up, completed version of this script as shown in the video and on the blog, or would like access to an extended version with functionality which will allow you to change the orientation of the stripes, add a random reduction of stripes, or change some of the display properties, then please check out the link in the description on my blog, generative-landscapes.com. Thanks for watching.